Welcome to lecture number 21 of Signals and Systems. To summarize about the previous session, we started to understand the system behavior when it is represented using a differential or difference equation. We are representing a discrete time system using difference equation, and on the other contrast, we are representing the continuous time system in using differential equation. In previous session, we touched upon the homogeneous solution and particular solution. The homogeneous solution is the one when the input is not forced or zero input. We also call it as natural response. The particular response or the particular solution is the one when the input is forced. It is also named as a forced response. In today's session, we are continuing with the complete solution. The complete solution is the sum of homogeneous solution and particular solution. Let me share my screen. In lecture 21, we are studying about chapter number 2, time domain representation of LTI system. The topics covered in this session are solving differential and difference equations. The continued part, we are looking upon complete solution, which is a sum of homogeneous solution and particular solution. Before we proceed with a complete solution, I had given you three assignments: homogeneous solutions 1 assignment and particular solutions 2 assignment. Homogeneous solution assignment was quite simple, so that's why I did not plan it to touch upon. Wherein the particular solutions assignment, the discrete time systems I did not take as an example in the last session. Hence, I'm taking this assignment solution also. So to begin with, so here the input given is, you know that whenever I say particular solution, the input is forced. You find that x of n is given, it is 2. And y of n minus 9 by 16, y of n minus 2 is equal to x of n minus 1 is the system. This is system and this is input. And we need to find the particular solution. To find the particular solution, we need to refer the table of previous session that I had given for the particular solution. There we understood that if the input is constant, the output, the particular solution is of the form constant. The particular solution is of the form y p of n is equal to c, some constant. It is a form of the particular solution. I wrote it by referring to the table of previous session. Now substitute it in equation 1. So when I substitute, in place of y of n I put c 9 by 16. So y of n minus 2. So you write it as c because it is constant. Irrespective of whatever shifting you do, so it is just a constant. Just write it as c equal to, the input is 2. So if I now take the common, I solve it in a quick session. So this is 16, c is equal to 2. You get it as 7c equal to 32. Therefore, c is equal to 32 by 7. So therefore, the particular solution is yp of n is 32 by 7 because I replaced c with 32 by 7. That is what I got. This is a particular solution. Very simple. When the input is given as constant. Now in the second assignment, I had given the input as 1 by 2 raised to n. And the system is represented as so and so as it is given here. Now when the input is of this form, the particular solution form will be in this fashion. Yp of n is equal to c into alpha raised to n. What about alpha here? Alpha is c into 1 by 2 raised to n. Right? In place of alpha, I am having 1 by 2. Okay, whenever your input is in the form of alpha raised to n, your particular solution form is c into alpha raised to n. So I replace alpha with 1 by 2. So this one I substitute it in equation 1. Let me represent this as equation 1. So we get it as yn should be written as c into 1 by 2 raised to n plus 1 by 4 y of n minus 2 should be written as c 1 by 2. So in place of n, I substitute it as n minus 2. This is equal to, input is just 1 by 2 raised to n and plus 2 into x of n minus 2 means 1 by 2 raised to n minus 2 because n is replaced with n minus 2. Now what I'm supposed to do here? So here what I do is I do some simple mathematical simplification. I multiply throughout with 1 by 2 raised to minus n. So if I multiply throughout by 1 by 2 raised to minus n, so minus n plus n get cancels, you will get it as c plus 1 by 4 into c 1 by 2 raised to minus n, and this is plus n cancels, and you will be left with 1 by 2 raised to minus 2. Okay, next this is equal to, this cancels, 1 2 into 1 by 2 raised to plus n and minus n cancels, you will be left with only minus 2. So if you solve this, I get as c plus c. So 1 by 4, it is 4. 1 by 4, and this is just 4. 1 by 2, 1 by 4, it is raised to minus. That's why I am taking it in this fashion. 1 plus, this is 2 into just 4. So I get it as 2c, because this cancels, 2c is equal to 9. 8 plus 1 is 9. So therefore, c is equal to 9 by 2. So substitute it in the particular solution. Therefore, particular solution becomes c. In place of c, I write it as 9 by 2. Here, c, I write it as 9 by 2. And here it is 1 by 2 raised to n. So this is a particular solution. So I hope the things are clear about your assignments. If you have done it, please compare your answer with this. So with this, we are proceeding to the last topic of the part 2 of chapter 2, that is differential and difference equation, the complete solution. To solve the complete solution, we have 3 steps. To solve the complete solution, we have 3 steps. First being, you need to find the homogeneous solution form, that is YH, from roots of the characteristic equation. The same thing what we did while finding the homogeneous solution. Next is find a particular solution from YP, form YP. This is the thing that we did just in the previous session. I just know what we did. Last step is the only addition plus delta that we are supposed to do. That is, determine the coefficient and homogeneous solution. So homogeneous solutions will be having like C1, C2 constants and all. You need to find the coefficients of that, and then you need to add homogeneous solution and particular solution in order to get the final complete solution. So here you should remember one thing. I have written as note. If initial conditions are specified, it should be applied after step 2. Means if initial conditions are given while we were finding homogeneous solution, directly we were substituting there, then and there itself. Now here you should not supposed to do it. First write the general form of homogeneous solution by referring to the roots of the characteristic equation. Then particular solution, solve for it. Add these two things, you will get a general form of complete solution. Then apply the initial condition. That's the meaning. So that is, initial conditions are applied to the complete solution form only. That you should remember. Okay, so people go wrong here. Immediately after solving for homogeneous solution, they apply the initial condition. That's the wrong way. Okay, you need to wait until you get a complete solution form and then you should proceed. So with this, we are starting up with the example number 1. That is, determine complete solution. System given as y of n minus 1 by 4 y of n minus 1 equal to x of n. This is a system given. Input, x of n is equal to 1 by 2 raised to n u of n. Initial condition is given as y of minus 1 is equal to 8. These are the things in the question. Now homogeneous solution, equation, how to be written, how it should be written? Just make the input 0. That will give you homogeneous equation. Let me do it. Y of n minus 1 by 4 y of n minus 1, that is equal to 0. This is homogeneous equation. Now characteristic equation, just replace the y of n with r raised to the r raised to k. So here k is 0, so hence I write r raised to 0, which is 1, minus 1 by 4 r raised to, here k is minus 1, write minus 1. Okay, so this is equal to 0. Okay, so you get it as 1 minus, or else I'll multiply r throughout. So I get r into 1 r minus 1 by 4. R into r raised to minus 1 is 1. So you will get it as r is equal to 1 by 4. There is only one root. Now if I ask you to write the homogeneous solution, the form will look like yh of n, because it is discrete time. You get it as, you have a root, I have single constant, I write it as c1 r raised to n. So c1 in place of r, I have got it as 1 by 4 raised to n. So this is homogeneous solution. I name it as equation 1. Equation 1 is already named. I name it as equation 2. Now coming to the particular solution form, look at the input. Input is of the form 1 by 2 raised to n into u of n. See, if this is the input in the same assignment 1 by 2 raised to n, this was the kind of the input. What was the form of the particular solution? It is c into alpha raised to n. Same thing here. The form is given by c into alpha raised to n. So make sure that this c and this c are different, or else I use a formula or denotation called cp into alpha raised to n. So I write it as cp, in place of alpha I am having 1 by 2 raised to n. Okay, so you can either use cp or k, whatever is your wish. Fine. So now I name it as 3, because this form I need to substitute in equation 1. Substitute it in equation 1. What do you get? You get it as, in place of y of n, I substitute it as cp 1 by 2 raised to n minus 1 by 4. It is n minus 1, y of n minus 1. So I write it as cp 1 by 2 raised to n minus 1 is equal to, x of n is, it is given by 1 by 2 raised to n u of n. U of n, we will generally write it later, or else we write it in this fashion. Normally n is greater than or equal to 0. That is what we write. Now we multiply with 1 by 2 raised to minus n throughout. So by doing it, what we get? We get it as, this cancels. Only cp is left. Here 1 by 4 cp plus n minus n cancels. You will get it as 1 by 2 raised to minus 1. This is equal to, this cancels. You will get it as 1. So cp minus 1 by 4, this will give you 2. 2 and this 4 cancels, and you will get 1 by 2 cp equal to 1. So if you solve it, you will get it as cp is equal to 2. Cp is equal to 2. Now the final particular solution yp of n is given as, refer 3 and write it. In place of cp, I need to write 2 into 1 by 2 raised to n. So I call this as 4. Fine. This is a particular solution. I mark ticket. This is a homogeneous solution general form. I ticket. So 2 and 4 will be useful for me for the next section. So here, using equation 2 and 4, we get complete solution. Complete solution is given by y is equal to yh plus yp, that we know. So by referring equation 2, I write yh. So yh is c1 into 1 by 4 raised to n plus, and yp is 2 into 1 by 2 raised to n. 2 into 1 by 2 raised to n. So this is a general form of complete solution. Now we have to apply the initial condition. This I denote it as equation 5. The initial conditions given in the question as y of minus 1 is equal to 8. This is what is given. Fine. This is a given entity. Now I substitute here. This is actually y of n. So y of n, in place of n, I substitute minus 1 is equal to c1 1 by 4 minus 1 plus 2 1 by 2 minus 1. Fine. So this is given as 8. This is equal to c1 into 4 plus 2 2s are 4. So 4 I take common, I get as 4 C1 plus 1. So this will give you C1 plus 1 is equal to 2. So C1 is equal to 1. So if I take on this side, this will give you 1. So the final complete solution is given by y of n is equal to 1 by 4 raised to n, because C1 is 1. So I no need to write it. Plus 2 into 1 by 2 raised to n. So write this condition, n greater than or equal to 0, because u of n was given for the input. So this is the solution for the problem 1. Very simple. I hope there are no doubts up till now. Now, I take the second problem, which is bit generalized. So in the previous problem, if you check, everything is same. X of n is 1 by 2 raised to n. Of course, initial condition is not given. Let us not worry. The equation, system equation, if you check, y of n minus rho y of n minus 1 equal to x of n. So in previous case, it is y of n minus, in place of rho, I am having 1 by 4. Rest everything is same. Rest everything is same. In general, I am showing it. Okay. So homogeneous solution, quickly if I go on writing, so I write the equation first. Rho x of n is 0. This is homogeneous equation. Characteristic equation is 1 minus rho r raised to minus 1 is equal to 0, or else so multiply by r minus rho is equal to 0, or else you can write r is equal to rho. This is a root, right? So homogeneous solution is of the form YH of n is given by C1 R1 raised to n, or else you can write C1 R1 is rho here, rho raised to n. This is a, I call this equation as 1, this equation as 2. Now particular solution form is, quickly we go on writing Yp of n. So look at the input. So your particular solution is Cp alpha raised to n, in place of alpha I am having 1 by 2, 1 by 2 raised to n. So substitute it, you get, so I directly write Cp 1 by 2 raised to n minus rho Cp 1 by 2 raised to n minus 1. This is equal to 1 by 2 raised to n. By multiplying 1 by 2, multiplying 1 by 2 raised to minus n, we get it as Cp minus rho into Cp 1 by 2 raised to minus 1. This is equal to 1. So if you solve it, you get it as Cp I take common, I get it as 1 minus 2 rho. This is equal to 1. So therefore Cp is equal to 1 divided by 1 minus 2 into rho. So this is your constant. Rho is a general quantity, hence if it was like some quantity given, you would have got some constant. Let us keep it as it is. So your particular solution becomes it is given by here Cp, in place of Cp I write it as 1 by 1 minus 2 rho 1 by 2 raised to n. Thus I name it as 3. Okay, so using these two reference, I write the complete solution. Complete solution is y is equal to yh plus yp. Therefore y of n is equal to yh is c1 rho raised to n. You can refer the equation 2, and equation 3 is here, plus 1 by 1 minus 2 rho 1 by 2 raised to n. Very simple. Okay, so this is the final equation, because I don't have any initial conditions given. So this is the final answer. To just compare with the previous example. In previous example, if you compare, in place of rho I am having 1 by 4. In place of rho I am having 1 by 4. Let me just put rho is equal to 1 by 4. Let us see we get the same thing or not. We get it as C1 1 by 4 raised to n plus 1 by 1 minus 2. Here it is 1 by 4, 1 by 2 raised to n. So this will give you C1 1 by 4 raised to n plus, so 2 and this 2 cancels, half, 1 minus half is half, so that will come to the numerator. So you get it as n. So this will match the previous session. Of course, with initial conditions same, if I give, you will get it as C1 equal to 1. Same thing, you will get it as the first problem. First problem, same thing. C1 you ignore right now because initial conditions are not given. 1 by 4 raised to n plus 2 into 1 by 2 raised to n. Same thing is here. Okay, so just to have a general touch, I have taken that example in front of you. Now the next one, I have slightly changed the input. So input is e raised to minus t u of t. If you remember the table of the homogeneous solution and particular solution, you please refer it. So by referring it, you can come to know that, so for input e raised to minus t, what should be the homogeneous of character solution form. So let us go one by one. Let us write one by one. So homogeneous equation to be written as, this becomes equation 1. These are the initial condition. The homogeneous equation means input should be made 0. D square by dt square y of t plus phi into d by dt y of t plus 6 into y of t. I have to make it 0. So this is the homogeneous equation. Now characteristic equation is, replace d by dt with r square plus phi r plus 6 is equal to 0. If I want to factorize it, I get it as r square plus 3r plus 2r plus 6 equal to 0. You get it as r, taking common, you get it as 3 plus 2. If you take common, you will get it as 3. So r plus 3, r plus 2 is equal to 0. So roots are r1 is equal to minus 3 and r2 is equal to minus 2. Find homogeneous solution form as yh of t. So look at the roots. Roots are real and they are not same. Hence, the homogeneous form is C1 e raised to R1 t plus C2 e raised to R2 t. So if I write it with reference to the roots that I have got, C1 e raised to R1, in place of R1 I have minus 3t plus C2 e raised to minus 2t. So thus I name it as equation 2. So right now the initial conditions are given, but you are not supposed to put it here. Okay. So homogeneous solution is formed. Now the next thing is you need to find the particular solution. So particular solution form, since your input is given as e raised to minus t into u of t, the particular solution form is yp of t is equal to e raised to, or c into cp, I write constant as cp, e raised to minus t. This is a form of particular solution. Now we need to substitute it. Substitute it in 1. So 1 is here. 1 is here. Substitute it. D square by dt square, same thing. D square by dt square cp e raised to minus t plus phi into d by dt of cp into e raised to minus t plus 6 into cp e raised to minus t equal to x of t. X of it is e raised to minus t into u of t is given. So let me write t greater than or equal to 0 for that purpose, because u of t is multiplied with it. So now what I am supposed to do is, you know that e raised to minus t's differentiation will give you minus into e raised to minus t. One more time differentiation will give you one more minus sign, though those two minus signs will cancel. Hence you get it as cp is a constant taken outside. You will get the same thing because 2 times minus sign gets cancelled. Here only one time differentiation, there will be a minus sign. Phi cp e raised to minus t. I guess it's the same problem what we took for homogeneous or particular solution example. So you can refer later. So this is as it is. So now dividing throughout by e raised to minus t, we get throughout by, so division, this is division by e raised to minus t, that you get it as cp minus phi cp plus 6cp is equal to is equal to 1. So this will get you Cp is equal to 1 by 2. So now this 1 by 2, because if you compute it, you'll get then in the same manner. So substitute it in the particular solution form. So particular solution form is given by, in place of Cp, I write it as 1 by 2 into e raised to minus t. This I name it as equation 3. Now coming to the complete solution. The complete solution is y of n is equal to yh, it's discrete time, so I write it as t, yh of t, yp of t. So substitute from equation 2 and 3. Equation 2, I have got it as c1 e raised to minus 3t plus c2 e raised to minus 2t plus, write the particular solution, 1 by 2 e raised to minus t. So this is your complete solutions general form. I call it as equation 4. So up till now, we are at some stage. We have not yet applied the initial conditions. Now apply initial conditions. So initial conditions, what they are given, just to note it, y of 0 is equal to minus 1. So y of 0 is equal to minus 1. Put it y of 0 here. Y of 0 is equal to c1 e raised to minus 3t. So t replace t with 0. So you get it as 0 plus c2 e raised to 0 plus 1 by 2 e raised to 0. You get it as c1 plus c2 plus 1 by 2. In place of y of 0, I'm writing minus 1. So if you substitute or if you simplify it, you'll get it as c1 plus c2. I take 1 by 2 on the other side. So you get it as minus 1. Uh, so here, one second. So y of 0 is minus 1 by 2. Y of 0 is minus 1 by 2. I wrote it here, just minus 1. Minus 1 by 2 it is. So minus 1 by 2. So this also, if I take on the other side, minus 1 by 2. Both if I add, I get as minus 1. This equation, I name it as A in order to solve the constants. Now, the next condition is given as d by dt of y of t, t when t is applied 0. So that initial condition is half. So d by dt of y of t when t supplied with 0 will get me 1 by 2. This is the next condition. But before that, I need to take the differentiation of the solution that I have got. So differentiating equation 4. Differentiating equation 4, because that's a complete solution. That complete solutions answer y of t we got, that you need to differentiate. If I differentiate it, minus 3 will come out, c1 minus 3c1 e raised to my. So I write it for your reference first time because it's a new problem. So I write it here. So d by dt y of t is equal to d by dt c1 e raised to minus 3t, okay, plus d by dt c2 e raised to minus 2t plus d by dt of half e raised to minus t. This is what you need to solve now. So if I solve it, I get it as this is equal to minus 3 c1. Minus 3 is a constant. Minus 3 after differentiation, c1 is a constant, e raised to minus 3t. Here also minus 2 c2 e raised to minus 2t. Here plus, not plus, minus half e raised to minus t. So when I substitute the initial conditions, t equal to 0, so I get it as, so I have to supply the same thing with t equal to 0 here. So I get it as 1 by 2 is equal to minus 3 c1 e raised to 0 c2 e raised to 0 e raised to 0. 1 by 2 is equal to minus 3 c1 minus 2 c2 minus 1 by 2. So this gives me 3c1 plus 2c2. So what I did is I took on the left hand side, this I took on the right hand side. I get as minus 1. So I name it as equation B. Now I have two equations, equation A and equation B. Equation A I just write it here. C1 plus C2 is equal to minus 1. This was equation A. So by solving, you solve it because you know it. For simple things, let us not waste time. So you get it as by solving C1 is equal to 1 and C2 is equal to minus 2. This is what we get. You can cross check. Okay. So now put it in the complete solution. Put it in equation 4. If I'm not wrong, equation 4. Yes. In place of C1, C2, you put it this one. C1 means y of t is equal to C1 is 1. C1 is 1. Just write e raised to minus 3t. Next, C2 is minus 2. So in place of C2, I write minus 2. E raised to minus 2t plus 1 by 2 e raised to minus t. This is for t greater than or equal to 0 because x of t is given as e raised to minus t u of t for that purpose. Therefore, y of t is equal to, you can write it as e raised to minus 3t minus 2 into e raised to minus 2t plus half into e raised to minus t u of t. This is the solution, complete solution. So we shall proceed with the next example. So here the input is cos t u of t. Initial conditions are here. The equation is given here. Homogeneous equation is just write the same thing by making x of t equal to 0. So d square by dt square y of t plus 3 into d by dt of y of t plus 2 into y of t is equal to make x of t equal to 0. So this is your homogeneous equation. Characteristic equation, replace d by dt with r square plus 3r plus 2 is equal to 0. Solve for it, factorize it. R square plus 2r plus 1r plus 2 is equal to 0. R if I take common, r plus 2. 1 if I take common, r plus 2 is equal to 0. You get it as r plus 2, r plus 1 is equal to 0. So therefore you have two real roots. One is r1 is equal to minus 1 and the other one is r2 is equal to minus 2. Now, so homogeneous solution form can be written as by looking at the roots. Real roots are there. Hence, yh of t is equal to c1 e raised to r1 t. So in place of r1, I am having minus 1 t. Correct? Plus c2 into e raised to r2 t. R2 is minus 2 t. This is equation 1. This is equation 1. The particular solution form is, look at the input. So input is cos, either it is cos or sine. The form of the particular solution is yp of t is equal to cp1 cos t, cos omega t, omega is 1 here, that's why cos t, plus cp2 sin t. This by referring to the table. Refer table of particular solution of previous session. Okay, so from there I'm taking it. Fine. So now you have to substitute it in equation 1. There you need to substitute. Equation 1 is here. D square by dt square y of t means this one you have to substitute. Cp1 cos t plus cp2 sin t. Cp1 is constant 1. Cp2 is constant 2 of particular solution. 3 into d by dt. So this one again you substitute. 2 into this one again you substitute. 2 into x of t. X of t is cos t u of t. Okay. So after substitution I get here d square by dt square cp1 cos t, same thing I have substituted here. Let us simplify it further. So you should be very careful while simplifying. So double differentiation of cos will generate you a minus sign and back the cos t, minus cp1 cos t, here also minus cp2 sine t. Here again, one time differentiation of cos will generate you minus 3 cp1. Differentiation of cos is sine t, and here differentiation of sine is plus, so plus 3 into cp2 cos t. Okay, so here plus cos t's differentiation, no differentiation at all here, just write it as it is, and here 2 into cp2 sine t, this is equal to, this is equal to 2 into cos t. Let us not write u of t, later on we will take care of that u of t. Okay, so now we have to just separate the cos terms and the sine terms, and then we have to compare the right hand side and the left hand side. Let us do that. So cos t terms, let me mark it here, here, and here. So let me write it here, minus cp1 minus cp1 plus 3 cp2 plus 2 cp1. So this is the terms of cos t. Okay, plus now we have to write the terms of sin t. Sin t's terms are remaining terms. These are the remaining terms. So write it, minus cp2, then minus 3 cp1, then plus 2 cp2. This is sin t. Correct? So we separated the components of sine and cos. So then the right hand side is 2 cos t. Now by comparing RHS and LHS, by comparing, we get LHS and RHS. Cos t's coefficient should be compared with cos t. Sin t's coefficient should be compared with sin t. Sin t coefficient is 0 here. So cos t coefficient is 2. So I get it as minus cp1 plus 2 cp2. cp1 will get me, if I compare this one, I get 2 cp1 minus cp1 is just cp1 plus 3 cp2 will get me 2. Similarly, if I compare the sign terms, here cp2 and cp2, 2 cp2 minus cp2 is just cp2, so I get it as minus 3 cp1 plus just cp2, coefficient is 0. So I'll solve this one first because it is very easy. cp2, this I take it on the other side, 3 cp1, or else let me keep it here, let me solve this itself. So what I do is I substitute 3 cp2 in so cp2 equal to 3 cp1 in this one, cp1 plus 3 into, so the here also I substitute 3 cp1 is equal to 2. So 9 cp1 plus cp plus 1, 10 cp1 is equal to 2. So therefore cp1 is equal to 2 by 10 is 1 by 5. So now I have to put it here. So this one I have taken here. Now I'll use it here. cp2 is equal to 3 by 5. So these are your particular solution. So therefore the particular solution looks like, so we were solving particular solution if you forget. So yp of t is equal to 1 by 5 cos t plus 3 by 5 sin t. Big problem, right? So this is your homogeneous solution form is equation number 1. Particular solution form, this is a general form. Now we arrived at the main form. This is a final particular solution. I name it as this equation is 2, this equation is 3. So this is homogeneous solution and particular solution. Now we shall go with complete solution. For complete solution, it is sum of homogeneous solution and particular solution. So I'm writing here homogeneous solution, this is particular solution. I have already written it. So now for this, we need to supply the initial conditions if they are given. Let us check if they are given. So they are given. So substitute the homogeneous given conditions. Y of 0 is equal to minus 4 by 5. Or else one more thing is differentiation of this. We will first differentiate it. Dy by dt will give me, differentiation of this will generate minus c1 e raised to minus t. Differentiation of this is minus 2 into c2 e raised to minus 2t. Differentiation of this cos is minus 1 by phi sin t. Differentiation of this is plus 3 by phi cos t. This is differentiation. Now I supply the initial condition. Initial condition says y of 0 is equal to minus 4 by phi, and y dash of 0 is nothing but differentiations. Y dash of 0 is nothing but this one. This is 3 by 5. Let me cross check once again. Minus 4 by 5, 3 by 5. Minus 4 by 5, 3 by 5. Now first I substitute this one. So take this one. I substitute here. Y is equal to 0. Y of 0 y is equal to. So go on substituting 0. C1 e raised to 0 means 1 plus C2 e raised to 0 means 1 plus 1 by phi cos 0 is 1 plus 3 by phi sin 0 is 0. So this y of 0 is minus 4 by phi. This is equal to C1 plus C2 plus, so this is gone 1 by phi. So we get it as C1 plus C2. So I take it on the other side. So it will be minus 1 by phi. Minus 5 by phi is minus 1. I name it as A. Similarly, for this one, I substitute the y dash of 0 equal to 3 by phi. So 3 by phi is equal to minus C1 e raised to 0 is minus C1 minus 2C2 e raised to 0 is 1 minus 1 by phi sin 0 is 0 plus 3 by phi into 1. So you get it as 3 by phi minus C1 minus 2C2. You will get 3 by phi. 3 by phi and 3 by phi cancels. You get it as minus C1 minus 2C2. This is equal to 0. Or else simply I can write it as C1 plus 2C2 is equal to 0. Or else you can write it as, you can solve for these two equations. This one is B. Solving A and B. Solve A and B. That you can do by yourself. I directly write the constants. C1 we get it as minus 2 and C2 we get it as 1. So put it in the main equation. This one I had not named. Let me name it as 4. Put it in 4. We get as y of t is equal to C1 means minus 2 e raised to minus t, and C2 is 1 plus e raised to minus 2t plus write the particular solution 1 by phi cos t plus 3 by phi sin t. So this is the answer for the very big problem that we solved now. Just refer the input. Input is u of t. Hence, you have to write the output as u of t. This is the complete solution of the problem. So the next example is, the input is x of n is equal to only u of n. I'll be quick here, quick enough. So homogeneous equation is, this is discrete time one. So y of n minus 1 by 4 y of n minus 2 is equal to 0. This is homogeneous equation. Characteristic equation is 1 minus 1 by 4, because k is 0 here. Here k is minus 2. So r raised to minus 2 is equal to 0. So this will get me, multiplying by r square throughout. R square minus 1 by 4 is equal to 0. Therefore r is equal to plus or minus 1 by 2. So that I write it as r1 is equal to plus 1 by 2 and r2 is equal to minus 1 by 2. So homogeneous solution is of the form yh of n is equal to c1 r1 raised to n. r1 is 1 by 2 raised to n plus c2 r2 raised to n. r2 is 1 by 2 raised to n. This one I name it as equation 2. Now particular solution form is, when your input is constant, it is constant. 1 into u of n it's a constant. So your particular solution form is also constant. It is just Cp. Now substitute it in 1 will get me Cp minus 1 by 4 Cp, because constant will not be altered by time shifting. So input you get it as 2 into 1 plus x of n minus. So it's a past value. For that u of n will be having 1 itself. So therefore Cp you will get it as this one will be 3 by 4. This is equal to 3. So you get it as Cp is equal to 4. Hence your particular solution is 4. That's it. I name it as 3. Now the complete solution is combination of or addition of these two things. This is homogeneous solution. This is particular solution for n greater than or equal to 0, because there is a u of n. So given is the initial conditions, y of minus 2 is equal to 8, y of minus 1 is equal to 0. So you need to substitute here. So substitution should be done carefully, because we need to do it only for n greater than or equal to 0. So when it is n greater than or equal to 0, u of n is given. So don't directly substitute. Here it is n. Don't directly substitute y of n as y of minus 2. N equal to minus 2, n equal to minus 1. Don't substitute like that. You should start from y of 0. When you start from y of 0 here, what do you get? C1, 1 by 2 raised to 0 is 1. So leave it. Plus C2 minus 1 by 2 raised to 0 is 1. Leave it. Plus 4. Call this as equation A. Now what I do is I take the original equation. So that is here, this equation. Equation 1, I substitute y of 0. So if I substitute y of 0 in equation 1, you get it as y of 0. These all things I take it on the right hand side. I get it as 1 by 4 y of 0 minus 2 will give me minus 2. And then here 2x of n, x of n minus 1, that I am writing here, plus 2 into x of n plus x of n minus 1. These problems will appear only in discrete time when u of n is given and your initial conditions are of negative values. So that time this condition appears. So here what you are supposed to do is we are supplying n equal to 0. So here I supply 0. This is 0. 0 minus 1 is just x of minus 1. Now I compare these two things. This is a solution. This is a system equation. For both the things I supplied y of 0. So one equation got me C1 plus C2 plus 4. Other equation got me this one. Both are y of 0. Now compare, equate A and B. By equating it, we get it as C1 plus C2 plus 4 is equal to 1 by 4. Y of minus 2 means it is given as 8. Write it. Plus 2 into x of 0. 2 into x of 0. You just see here. X of 0, it is u of n. U of n is 1 there. So that's why I write 2 into 1. X of minus 1. Then it is u of n. It is minus 1. So hence you get it as 0, because u of n will be 0 when n is equal to minus 1. So when you solve it, you get it as, so 4 ones are 4 twos are 2 plus 2 is 4. So 4 on the right hand side, 4 on the left hand side. I take it on the other side. So you get it as C1 plus C2, 4 minus 4. You will get it as 0. Or else you get it as C1 is equal to minus C2. Now similarly, we need to go for next one. We should try for only n greater than or equal to 0. For n greater than or equal to 0, because it is u of n, so I substitute y of 1. So when I substitute y of 1, I get it as C1 into 1 by 2, C2 into minus 1 by 2. So it will take 2 more minutes, plus 4. And this is from equation 4. Now similarly for equation 1, what I get, I write it here. From equation 1, I get it as y of 1 in the same manner, 1 by 4 y of minus 1 plus 2 into x of 1 plus x of 0. This is by this one. So these two things I equate, I get it as C1 by 2 minus C2 by 2, this is C2 by 2 plus 4, write it. So what you get here, y of minus 1 means 0. So 0 plus, this is 2 into 1 is 2 plus it is 1. It is 1. So if you solve it, you get it as C1 minus C2 is equal to minus 2. So finally, C2 is equal to 1. So C1 is minus 1. C2 is equal to 1 means C1 should be minus 1 on the basis of the equation that we have solved earlier. We got it in this fashion. Okay. So therefore, final complete solution is y of n is equal to C1 is minus 1. So C1 is minus 1 minus 1 by 2 raised to n. Okay. Next C2 is 1. So plus minus 1 by 2 raised to n, because C2 is plus but inside it is minus 1, plus 4. You need to make sure that u of n is taken care. So this completes your fourth problem, and take this one as assignment. It is a discrete time on 2 raised to n. Check the table of particular solution and solve it. Get the complete solution. We'll discuss about it in the next session. We are concluding today's lecture. So thank you.